Okay, let's have a look at what is a forward rate agreement, or FRA. So in this example here, I'm going to buy a 6-month FRA on the 360-day LIBOR dollar time deposit. So this is a derivative contract on the interest rate for which the underlying is a 360-day LIBOR dollar time deposit. So this is called an FRA6X12. The forward contract has a duration of 6 months, and in 6 months' time it will be settled according to the rate on the 12-month or 360-day LIBOR rate. So expiry 6 months, underlying is a 12-month LIBOR time deposit. So by buying the FRA 6x12, the objective is to effectively hedge against a rise in the LIBOR rates in 6 months' time. So at expiry, a settlement is made either by the buyer or the seller in order to compensate for any changes in the rates on a 12-month LIBOR time deposit. So if I'm the buyer and rates go up, the dealer will have to make a settlement to me to compensate me for the rate rise, and if rates go down, I will have to compensate the dealer for the lowering of the rates, for the change in value of the notional, for a lowering of the rates. Okay, so let's work through the example. So at the time of, let's say that at the time of purchase, the LIBOR 360-day is at a rate of 0%. So right now the rate on LIBOR 360 is 0%. Okay, so then the present value of the time deposit will be as follows. So the present value of the time deposit 360-day will be equal to and the contract size I'm going to use in the example is $10 million. So I'll just move this down. Let's move this down. So I'll write it here. The notional value is $10 million time deposit. Okay. Present value is equal to the $10 million divided by so the current 360-day time deposit is discounted, $10 million discounted by 1 plus the rate 0%, and then to annualize that we've got to multiply the 0% by the 360 days outstanding out of 360 days in a year. Of course, the number of years here is effectively 1 year, so the result will be 1. But if it was 180 days, the result would be half a year, or 0.5. So expanding the calculation further, we've got present value of the time deposit at 360 days is equal to $10 million over 0% times 1 is still 0, so 1.00. So the present value of this contract, this makes it an easy example. The present value of the time deposit 360 is equal to $10 million. So there's no difference. Okay, now this is now, and now let's look at expiry. So at expiry, we'll have a 10 million, the underlying 10 million LIBOR 360. Let's say that now the rate has increased to 50. It's increased by 50 basis points. So the new rate is going to be 0.5% future. So the future value, the future rate is 0.5%. Okay, so let's work through the new present value. The present value at that time, of a time deposit of 360 days will be equal to the $10 million. So it's the same calculation, $10 million discounted by 1 plus the rate, 0.5%, multiplied by 360 over 360, so 300, so it's 1 year, so it's 1 year, and that will be equal to $10 million. 0.5% multiplied by 1 will be 0.5%, so the value we've got in the discount rate is 1.005. This is 50 basis points at 0.5%. So if we work it through, so the present value of the time deposit of 360 days is equal to open up the calculator, okay, so 10 million divided by 1.005 equals, what's going on, equals, so 9,950,000, 9,950,000, $248.76. Right. So there's a difference between the value now and the value in the future. So given that rates in the example have gone up and we were hedging against a rise in rates, that means that we are going to be compensated for the loss in the principal value. So we're going to be compensated for the rise in interest rates, and the compensation is going to be equal to the difference between these two sums. So because the principal value has lost, so let's minus, so 9,950,000 minus the original 10 million. So the future value less the current value, or the present value of the principal is equal to 9,950,000 minus 10 million. So the loss of $49,000, $49,751.24. So this loss will be compensated by a gain on the FRA of an equivalent sum. So to compensate for the loss, we will receive $49,751. So what's the benefit of doing this? Well, 6 months ago, when I hedged, I could borrow $10 million at a rate of 0%. Now that the rates have gone up, if I had not hedged, I would have to pay a rate of 0.5% now to borrow the same $10 million. But because I hedged, I can borrow I'll borrow now paying 0.5% or 50 basis points for the loan. But because I'm compensated by the gain on the FRA contract, it means that I continue to effectively borrow 10 million at a rate of 0. So even though I'm going to pay 50 basis points on the new contract, the hedge is going to compensate me the same 50 basis points, and my net cost of borrowing is hedged at 0%.